My name's Cynthia Thomas. I work at Midokura. We're a software networking company. We focused initially on OpenStack. We have ties into container networking, which I'm here to talk about today. I think even some of the points that Adnan had hit on, reusing tools that we have already and leveraging that with new technologies. We'll talk about that and how we're incorporating some older technologies, not necessarily old, but existing technologies and leveraging that instead of reinventing the wheel. Talking about Kubernetes and networking specifically, how to secure containers. Just want to get a feel for the crowd. Who's more on the dev side, like pure dev? And then DevOps is the remainder, I guess, or kind of? Or both, or looking into it? Okay. Just curious, just so we know what we're talking about here. Well, containers, obviously the hype has been going on since Docker brought it upon us, or made it easier to launch containers, forcing companies to work more towards developing cloud-native applications, and that's what makes containers easy and cool to use. And then, of course, Swarm, Kubernetes, Mesos are bringing that orchestration to actually deliver services. But yeah, some of the things that we're seeing repeated are the lack of networking services, and that's what I'm here to focus on today. And networking always seems like an afterthought. Even OpenStack, even networking itself, the way VLANs, the way that standard was initially written, it wasn't built to scale. And now things change when it's time to scale. So with containers specifically, what's the problem? Why are they insecure? Even what we're seeing on the OpenStack side is, okay, let's just shove a bunch of containers in a virtual machine, and that'll make the isolation happen. And things are not totally isolated on a box, even though you're getting the advantage of being lightweight, not repeating the OS all over the place. So not everything in Linux is namespace. So SE Linux and C groups, these kind of things are sort of being shared on a physical host. So there's definitely some problems there. And then what do they do to the network? Well, even some of the initial instantiations of the networking that we're seeing in Kubernetes, there's a shared networking stack. And therefore, there isn't true isolation. So what else do they do to the network? Well, they're adding complexity. So they're adding a bunch of more endpoints on the network, on the physical network, if you want to think of it that way. And that means more MAC addresses, can top-of-rack switches, are they able to handle this growth in the number of endpoints? Just pure scaling issues, especially for dealing with higher layer services, let's say firewalls, where you implement that in a network, and it introduces a lot of complexity in terms of security. So, previously in legacy architectures, typically you have, all your computes are somewhere in your data center, and you typically have your firewalls as your gateway, sort of in and out of the node. So that's fine for north-south traffic flows. But what containers have brought and virtual machines have brought in the data center is a lot of east-west traffic. And that traffic's not necessarily supposed to talk to each other. So these firewalls are there, and then they introduce these hairpinning of traffic flows. So you get a lot of inefficient networking and things coming up and down the data center. And then some of the resolution behind that were attempts at putting virtual machines in parts of the network that might have that virtual machine as like a virtual appliance from your load balancer or firewall company. But then you start having to manage where do you put those in relation to the rest of your network and components that are in the network. So what Kubernetes can do today, so initially obviously started as totally flat network. Everybody could see everybody. Now the network policy is in the development, it's beta stages, but that at least allows for you to define a service and apply a label and say where it should go. So you're basically, though, the only problem is it's limited to the ingress. So it's an ingress policy. You don't get more of the detailed, fine-grained security policies that you might already get from existing frameworks, which we'll about to talk about. But the plus is, with Kubernetes, obviously, it allows for a pluggable nature. Kubernetes is made up of several constructs in its architecture, and it's sort of meant to be a best of breed, between the scheduler or the components that reside on the worker node, like the queue proxy, for example. So these things are meant to be interchangeable. But so one example that we're seeing more is Kubernetes and IoT, just like food for thought. How is this affecting the network? Well, Kubernetes has that best of breed type mentality. So you can bring services to different architectures. Here in IoT, you're having this you're merging of IT and OT, for example, in industrial IoT, where you might have all these sensors on the factory floor. So you have tons more endpoints. Containerizing some of these applications that might reside at these ancillary locations, benefit from being in Kubernetes because it's lightweight, it's manageable. You could put it at an IoT gateway, for example. But then in turn, how does it affect the network? How do you handle all those extra endpoints and provide security and monitoring and all these things? So when it's time to actually go to production, who's actually going to care? As a developer, developer might be really excited they did everything Kubernetes or containers and they're ready to go to production. And then the big, gatekeeper is going to be that security person in your organization. And the network team, the network security team is actually going to be the people who care. And that's why we want to talk about security and networking earlier, so you have that idea of what would be a solution that helps me deploy my application, but enables me with the right tools so that I can go to production. So I don't know, how many people are familiar with OpenStack in the audience? Okay, many people. Okay, great. So OpenStack is kind of an example. It was just like Kubernetes is being developed, and it's getting really hot right now, obviously, with a lot of users. OpenStack is the same way. It's been in the works for the last 6 years. It's an open source community, has tons of contributors, but it was an example where networking was totally an afterthought there as well. Initially, it was just part of Nova Network under the compute service. And so this framework for networking was totally an afterthought. But it was exciting to have this open source technology that people could launch and take advantage of. So eventually Neutron came to be, and Neutron is the name of the project within OpenStack focused on the networking framework. And it's grown. It enables a third-party plugin. It has all this type of functionality that's very important to networking people and security people. And there's various ways to achieve this, whether it be through direct plugins or overlays, which is what Midokura does. But you get all this type of functionality. So bridging subnets across your data center for a networking person, that's really scary because you have to do things like spanning tree if it was a physical node. But this is where overlays can help. Layer 3 routing. So just a host full of things that you can do with functionality that's been well defined. We're not going through the same community politics to argue what the framework is, because networking is networking in the end. So why reinvent the wheel? So some of the hardened plugins that you might know out there, OVS, one of the default reference architectures, Calico, PlumGrid, Nuage, and then Midonet. So Midonet is what I'm here to talk about today, and its incorporation with Kubernetes. So the company I work for is Midokura. It actually started 6 years ago as well. So the CTO and the chief product officer is one of the co-founders. They used to work with Werner Vogel at Amazon. So their expertise is more on distributed systems. And Dan Demetrio and TK, so they're our co-founders. They actually went to start the Amazon of Japan. So that was back at that time, before Amazon was in there. And then what they discovered was networking was the problem. And then eventually Amazon came in there too. But they ended up seeing that networking was a real problem on these cloud compute implementations. So they decided to focus on networking specifically. And we've also been involved with OpenStack since the B release. So this Midonet has been in the works in engineering. We started as an engineering company predominantly, but it's been in the works for 6 years. And we were involved in a lot of the standardization of the networking framework. So our expertise is networking. And then as of 2014, we actually went completely open source. So all of our code is available on GitHub for anyone to try. But what's special about Midonet is it achieves these networking functionality services as an overlay and in a completely distributed manner. So that was their goal. Coming from a distributed systems background, it was important for them to build a solution and architecture that scaled with the likes of Amazon with their experience. And so that's what the beauty of Midokura is. The power of the network grows as your compute nodes grow. And here we have examples of some of our services on CoreOS, containerized, for bare metal Kubernetes type deployments, and then with OpenStack as well. So these agents are residing on the edge, and they do all these network functions. So it's avoiding the hairpinning that you're getting to service appliances like firewalls. We're applying network policy right at the edge. So that's the beauty of Midokura. You're not sending unnecessary traffic that might eventually get dropped. We have security group policies, so whether they be ingress or egress on this logical topology. Let's say one pod wanted to talk to another pod, and they're completely different tenants. We would drop it if the policy said before it even leaves the host. So you get a lot of these efficiencies, with Midokura. And then we also have a distributed gateway functionality also for coming in and out of the cloud. So that's really powerful too, since you have the ability to scale for north-south traffic flows. And we're a complete software play also, so we don't rely on a particular hardware vendor. These are all like x86 boxes. So yeah, I talked about the security that happens at the edge. When a pod or container starts talking and communicating, basically this agent is intercepting that traffic and does a simulation over this logical topology. And that's where it figures out if there's any kind of policy in the entire network topology that means to drop the packet, it will do it right there, or it will manipulate the packet. In terms of Kubernetes, let's say there's a service that's being provided, we'll be natting it and providing the service to the backend container wherever it may reside. So we manipulate the packet that way, and then we encapsulate it with VXLAN, and we can send it over any infrastructure basically. So there's no dependencies on the underlying infrastructure. So that's what Midokura does. Its initial use case being OpenStack, so it's a hardened networking product. But has anybody ever heard of Courier? A few? Okay, cool. So for those who don't know, Courier, it's a Czech word for courier. So yeah, it's obvious, I guess, but phonetically speaking. So this is actually an open source project under OpenStack as well. It was actually initially started by 2 developers at Midokura. And the mission there was to bridge container networking to OpenStack networking abstractions. So initially, in the initial foundation, it was using the container networking model from Docker and then translating that to Neutron. And then, obviously, since I'm here at a Kubernetes workshop or a Kubernetes meetup, the purpose is to take the CNI translation and translate that to Neutron. So it's become basically a collection of libraries. So Courier libnetwork, the Courier Kubernetes focusing on the API calls from Kubernetes, and then some storage-specific ones as well. And it's been widely accepted by the wider community, so we have tons of contributors to that as well, which is great. So from a networking perspective, how this translates in Kubernetes is it's taking these Kubernetes constructs and just translating them to Neutron, which was already the framework that we had defined from OpenStack. So that's why any Neutron plugin can fit in to Kubernetes environment with Courier. So the goal is to tie, under one SDN, you can tie different types of workloads, whether that be from virtual machines, Kubernetes, container workloads, eventually bare metal. So anytime there's an instantiation from a Kubernetes API call, it can be translated basically to a Neutron API call. And that in turn, whatever SDN vendor you're using, like Midokura as one example, can do what it does usually in the back end. So whether that does the binding, handles the networking services the way it usually would, all these API calls are just there for the setup. So why is this important? Well, what I started the talk by mentioning is why reinvent the wheel? We're seeing that when there's a new technology that comes out, networking is left to the end, and when it's time to go to production, that's when we face the issues of what was missing. So here are some of the gaps between what Neutron has been able to accomplish and where Kubernetes is sort of catching up, and it's becoming more and more prevalent as people go to production. So multi-tenancy is something that Neutron provides. The flat networking versus overlapping IPs to provide, well, that kind of goes hand in hand with multi-tenancy as well. The security group and policies are much more rich on the Neutron side, so they can be applied to Kubernetes pods and containers. It's just not native to Kubernetes yet. Eventually, the framework will be there, but you can go with your resilient Neutron plugin as a solution for networking. And then other various things like quality of service, which would become important. You might want to be throttling whatever this pod is. You don't want something to go hog your network bandwidth. And then, of course, the admin and tenant-facing APIs, they're pretty elementary right now on the Kubernetes side. So what I want you to imagine is all these more advanced networking services, policies. Think of it as being accomplished by a resilient solution, because they've been hardened over the years, and now applying it to Kubernetes, which is still more in its infancy. So I think probably everybody is pretty familiar with Kubernetes architecture. The components that might reside on the master node versus on the worker nodes. It's basically using this pull method for config changes, so the worker nodes need to pay attention. So that means we need to pay attention to the Kubernetes API whenever there's calls or changes made to the network. So I'll just talk a little bit about what the Midokura integration is with Kubernetes using Courier. So it was tested with 1.2 and up, so that's what it's available. And there's two main parts that are residing for this integration. So there's the CNI driver, the Container Networking Interface driver, and that is doing the binding on the physical host to provide that virtual logical topology of the networking services. And then Raven, which is paying attention to the Kubernetes API calls and doing the translation. So what you guys might be familiar with are the things that are residing in the default architecture. So kubeproxy sort of acting as the load balancer on the worker nodes, and Flannel is one example of a networking solution with more elementary or primitive logical topology availability. And then that's enhanced with Courier by the Courier CNI driver. So that's what's doing the host binding on the worker nodes, binding those containers, right, and identifying the physical hosts. And then the Raven is the agent that would be residing on the master node, so paying attention to the API calls and doing the translation. And then whatever, in this example, it's Midokura, but it would be whatever the SDN solution would be wherever or however it's implemented. So in this case, it's the Midokura agent that would be residing on the worker nodes. So as I mentioned, it's just basically doing this Raven's listening for these API calls that are coming from Kubernetes and just translating that to what Neutron knows as these agreed upon from the framework of the OpenStack community on the Neutron side, on the networking side. And these definitions obviously from Kubernetes, but these are more aligned with how networking people think of networking. And as you'll see that when we replace kubeproxy, it's providing that load balancing as a service basically at the end. And so in turn, these endpoints are your containers in your pod. They're basically being aligned as a load balancer pool member. So just depicting a little bit of how this looks. As I mentioned, the Raven would be sitting on the master listening for those Kubernetes API calls, and then the CNI driver is on the worker nodes along with the Midokura agent. So that's just a closer look at what the worker node is looking like. So this is all in its infancy, of course, just like Kubernetes is still developing as the network policy and network definitions continue to be defined. So we're keeping up with that. So the things that have been done are the CNI driver, the Raven process. These are coming from Courier. And then the namespace implementation. So that's still a little more in its elementary stages too. So basically they're all on the same namespace today. And then Core OS support, which was a big one for us because not big in terms of, I think it's a great milestone because now we're containerizing our services, and that's going to enable more things to come. So Courier as a project, there's still lots to be done, and that's the fact that it's an open source project is why we welcome contributors, and we encourage you to try it. But where we're at today is we want to bring the container and virtual networking under one API. And then obviously multi-tenancy aligning with Kubernetes needs to come in there as well. And then just getting more native Kubernetes API calls to be defined in order to translate to the higher layer services like QoS and other advanced policies, load balancing as a service, firewall as a service. And then the goal, as I mentioned, Courier, is to provide containerized networking, bridging it to OpenStack network abstraction. So there's a host of other platforms as well that are yet to be fed. Like so Mesos also relies on CNI as well. But this work basically needs to be done. And then Magnum is a specific project within OpenStack as well. That was the one I was talking about. That's putting the container orchestration engines within a virtual machine and having the definitions with bays to get that going specifically on the OpenStack side. But Courier will be complementing Magnum, so that's already been kind of gelled out, or is gelling, I should say. So yeah, as I mentioned, both of these projects are also open source. So these are things that you can try today. So I encourage you to get involved as well. The info is here. One thing that's in tech preview right now for you guys to just get up and going is if you go to the Medonet.org website. Actually, if you go to the docs.medonet.org, if you go to the Medonet website and then go follow to the documentation page, we actually have a tech preview of Courier and Kubernetes with Medonet. And so we give you a script just to get your master node up and running, as well as your worker node up and running. And so that's something you could try today, just tweaking the YAML file and get that up and going and try it out for yourself. So, so some of the more benefits too that I wanted to mention as well is what Medonet is bringing to Kubernetes. So some of the pluses are these more advanced security policies and logical topologies that you can build above and beyond the elementary things that are there today. The second thing being the ability to bridge different platforms with a single SDN instead of having different SDNs depending on what platform, so one API for both. And the third thing being actually Medonet's enterprise version has visibility into every single flow. So it's more of an operational tools advantage. So I think I even finished early, I think. So proud of myself for that.